PPOD is a cute acronym that stands for pea protein omic determination. The goals of the project were to understand genetic control of protein in peas, understand the properties and functionalities of pea protein for potential use in food ingredients, and to understand better the economic aspects of having high protein varieties in the marketplace and maybe the consumer perceptions of pea protein as a food ingredient.
The project itself is kind of multidisciplinary approach because this is kind of quite unique in a way. This project is involving from us in breeding, genetics, genomics, chemistry, and all the way to the consumer preference. So when you develop a product, you want to make sure that the product is meeting the healthy requirement, the chemistry is there, the component is there, and also acceptable to the end customer. The people will eat it. It's not just sitting on the shelf. So this is what this I said is unique.
During the course of the 6 years, we have made a significant advancement in identifying the key genetic markers and regions identified associated with seed protein concentration in pea. And we have developed the channels and pipelines to integrate this knowledge into the breeding pipeline. So that integration came from two different aspects. One, from the marker-assisted breeding, where we use individual markers for accelerated breeding. But for a complex trait like seed protein concentration, we also need to use more advanced models like the genomic prediction models to accurately predict the seed protein concentration. One of the aspects that greatly affects the seed protein concentration is the environment, which is equally important as the genetic basis of seed protein. So by taking into account both the genetic aspects and the environment and integrating them using some advanced models, and probably we also generated foundation for the future machine learning models. In this project, we explored the global pea germplasm and we identified the sources for seed protein concentration improvement in pea. In terms of genomic resources, we have developed the tools that helps the breeders to increase the selection efficiency, make more accurate decisions and faster decisions. And cumulatively, all of these will lead to breeding higher quality proteins and stabilize the yields and accelerate the variety development process.
One of the main outcomes arising from my component in the PPOD project, we were able to obtain higher protein extraction and protein yields in the fractionation process. This is really important when we look at expanding our secondary processing markets internationally and in Saskatchewan. It's also important to know that there was no differences in functionality, but we did see a little bit differences in nutrition. So the high protein lines were able to get higher protein, but a little bit less PD-Cas or protein quality numbers versus the lower protein. And that creates new opportunities to target different market applications for those two ingredients. Some of the major outcomes that arose from the PPOD is that producing high protein pea will allow us to create economic value of pea and create higher protein ingredients for the food market. Canadians are known for producing the highest quality pea around the world. This is going to give us a competitive advantage in Saskatchewan and Canada on the export markets.
I think the first one would be that labels really matter on plant-based meat alternatives. So for example, we found that products with shorter ingredient lists, with more familiar sounding ingredients, really resonate more with consumers. So thinking about taking those pea proteins and how do you simulate meat, it really matters that you can do it with as few ingredients as possible. We found that things like health and nutrition related information also really matters. So for example, being able to make a complete source of protein claim, that's a protein quality claim, on those food products that tended to attract consumers, more so than an environmental claim, which was kind of interesting. And then the second main thing that we looked at was motivations. Why do people choose these products? Why do they stop consuming them? Curiosity, people choose them because they're curious. Health, nutrition matters. So a lot of people are choosing these products because they think they're healthier. Influence of friends and family matters. And taste is really king. I think economics helps us understand two things in the context of this project. One would be where the benefits flow from investments in enhanced pea protein. So where does that flow in the supply chain, the benefits from that? And secondly, what's happening to the market, the demand for products made from pea protein? So how is that market changing? How is that demand pulling products through the chain?
I'm a plant breeder, so I'm really excited about new markers arising from pea pod. So these are like DNA markers that we can use routinely in breeding to select breeding lines with higher protein concentration. So that's a real exciting output for me. Secondly, I feel that we came to know a lot more about how, let's say, the functionality of the pea protein, and we came to learn that it would be beneficial to select high protein pea varieties because it would make protein extraction industries more efficient by starting with something that had a higher protein concentration to begin with. And maybe the final thing I feel that came out of the economic analysis was that, further support for pea breeding will accelerate development of varieties that are not only high protein, but high yielding, having good agronomics, having good disease resistance, and so on. And that will be to the benefit of farmers in Western Canada. It will be to the benefit of companies that are extracting protein from peas.